we're going to discuss a publication talking about how image analysis enhances colon cancer diagnosis. We're exploring a study where almost 24,000 annotations were made for 600 cases of colorectal cancer. And the beauty of this approach is that it used the visually recognizable features that are recognized and were known to be associated with prognosis by the pathologist. The pathologist annotated and then created a model to detect them and quantify them. So let's dive into it. I was impressed. So I was talking to Rish Pai, who was the co-author and leader of this project at Mayo Clinic. And when I was talking to him, I was impressed that they had actually 15 features. He built a model. It took him half a year, and he included 15 features, 15 different things that he was detecting with the software. They annotated, so they had here carcinoma versus stroma, and they evaluated tumor budding, and they evaluated solid versus glandular growth patterns, signet ring cells, necrosis, mucin production, different stromal subtypes, immune-rich stroma and immature stroma. Then they had TILs, immune cell infiltration, but that's more or less the same, probably. I don't know if maybe this was outside the tumor. Tumor grading, and they included the microsatellite MSI and MSS, stability and instability, and a few other features. So to me, the more, and I see a hand raised. Yeah, so to me, the more features, the more complex this model is, and the easier it is for it to fail. Go ahead.
Yeah, that's a quick naive question. So the microsatellites are actually coming from genomes, right? So
yes.
Are they adding genomic data?
Mm-hmm. So it was interesting way. I don't know if I don't have an image for that. But what they did draw it for you. So usually you just give examples of structures in the tissue. So everything that's here other than the instability is image data. And then what they did, they annotated the whole image and gave it a label, stable or unstable. And the label came from genomic data, but they didn't put a specific histopathological feature corresponding to the MSI or MSS. They gave the label to the full image. So I thought it was a pretty innovative way of doing weakly supervised image analysis in a software that was designed for classical supervised with annotations. So they included that as well. So they had these annotations over 24,000, and they had almost 600 cases, 15 features, and they used a database called Colon Cancer Family Registry. This is something that Rish Pai was working on. And they trained a prognostic model. So once they had all those features detected consistently, they then combined it to a prognostic model, and they staged it, and they also included the microsatellite instability status. They had a validation, and then they assessed the ability of traditional pathologic features to predict recurrence-free survival, and then they used the quant-CRC to do the same. They applied the ASCO risk scheme to predict, and here they did it with image analysis, and it worked. I thought, and thank you for this question. I thought this was a super cool way of incorporating genomic data into image analysis. So that's what they did for colorectal cancer. And this publication was actually from this year. The previous one happened earlier, I think, 2022. Yeah, this was 2022. And my favorite way of applying And I see another question. Go ahead.
Thank you. That's one study. There was a follow-on study in modern pathology in which they used the eosinophilic esophagitis histology scoring system very effectively. I got very good inter-rater agreement for most of the features that are in that scoring system. I think the major breakthrough has for that particular disease or any disease involving a lot of eosinophils is the ability to count eosinophils. And I think it was, I'm completely naive about these things, but allowing the machine to learn rather than telling the machine what is, what isn't, just allowing the machine to be taught rather than the way it used to be done. And now there are several programs that get very good correlation between the algorithmic quantitation of eosinophils and the human quantitation of eosinophils.
Yes. So you mean rather allowing the machine to learn from examples, right?
Yes, exactly.
Yes. So that's the exactly like you say, that was and it started happening 2016 was the first time I took a part in a project where I didn't have to say image analysis project, oh, this cell is that round and it has this level of brown. That was for IHC quantification of lymphocytes in, I don't know, some tumor entities. Around 2016, then in 2019, this made it into commercial software. And a previous way of doing image analysis, this was the classical computer vision approach, rule-based, whereas this one is example-based and is based on the deep learning architecture. So whenever you hear deep learning, that's going to be where you can give examples. And the next level is not really giving specific examples, but like what we had with the molecular data. You just say, this image has this molecular status. Go and figure out where this mutation can come from. And I don't have this example in my presentation, but this was applied in the clinic as well in Israel. I was super excited about this publication. Later at the end, when I finish, I'm going to show you which one that was when I find it. But yeah, basically when we can give examples, everything that's counting, like if I was in charge of anything and I'm not doing diagnostics at all, but if I was in charge of any of those scorings where people have to count something or estimate the percentage of something, I would like scrap it and mandate this to be done with image analysis. Because from the literature that I analyzed, the difference that a human eye physiologically can perceive between, for example, number of those dots, numbers of eosinophils, or like estimates, is 25% is when you start seeing difference. And the thresholds for all those companion diagnostics that are being used, for example, for PD-L1 scoring, this is 10%, and like this is beyond visual perception. So I would not do it. I'm not in charge of anything. This is just my personal opinion. Whenever there is counting involved, I would just not make people do it. I would make computers do it. Thank you so much for watching. I think it's beautiful to leverage the power of both pathologist expertise and their visual recognition of features with the power of image analysis. So if you want to learn more how to create your own algorithms in Aiforia, definitely check out their website. It's AI4IAimageanalysis.com, or check this playlist because there is a lot of educational content that will help you understand how to leverage image analysis for pathologies. And I talk to you in the next episode.